Hello everyone and welcome back to Math Hedgie. In today's video, we are going to tackle a very interesting problem on ordering numbers with negative exponents. The question is, arrange 8 to the power of minus 9, 4 to the power of minus 12, and 32 to the power of minus 5 in ascending order. Now when we see negative exponents, it is easy to get confused. But do not worry. We are going to break it down step by step. Before we jump into the problem, let us quickly recall two important rules from the laws of indices. First, the power rule. It says, a to the power of m, all raised to the power of n, equals a to the power of m times n. For example, 2 cubed raised to the power of 2 equals 2 to the power of 6. Second, the rule for negative exponents. It says, a to the power of minus n equals 1 over a to the power of n. This tells us that a number with a negative exponent is just the reciprocal of the positive exponent form. Now, if we want to compare numbers like these, the key is to express them with the same base. Alright, let us look at our numbers. We have 8 to the power of minus 9, 4 to the power of minus 12, and 32 to the power of minus 5. 8, 4, and 32 are all powers of 2. 8 equals 2 cubed. 4 equals 2 squared. 32 equals 2 to the power of 5. So let us rewrite each number as 2 raised to some power. For 8 to the power of minus 9, 8 is 2 cubed. So this becomes 2 cubed raised to the power of minus 9. Using the power rule, we multiply the exponents. 3 times minus 9 equals minus 27. So 8 to the power of minus 9 equals 2 to the power of minus 27. For 4 to the power of minus 12, 4 is 2 squared. So this becomes 2 squared raised to the power of minus 12. 2 times minus 12 equals minus 24. So 4 to the power of minus 12 equals 2 to the power of minus 24. For 32 to the power of minus 5, 32 is 2 to the power of 5. So this becomes 2 to the power of 5 raised to the power of minus 5. 5 times minus 5 equals minus 25. So 32 to the power of minus 5 equals 2 to the power of minus 25. Now we have 8 to the power of minus 9 equals 2 to the power of minus 27. 4 to the power of minus 12 equals 2 to the power of minus 24. 32 to the power of minus 5 equals 2 to the power of minus 25. But negative exponents can still be a bit tricky to compare directly. So let us apply our second index law, the one about negative exponents, to rewrite these as fractions. Remember, a to the power of minus n equals 1 over a to the power of n. So, 2 to the power of minus 27 equals 1 over 2 to the power of 27. 2 to the power of minus 25 equals 1 over 2 to the power of 25. And 2 to the power of minus 24 equals 1 over 2 to the power of 24. Now here is the key point. All these fractions have the same numerator, which is 1. When fractions have the same numerator, the fraction with the larger denominator is actually the smaller number. Think about it practically. 1/2 is 0.5, 1/4 is 0.25, 1/8 is 0.125. So 1 divided by a larger number gives a smaller result. Now let us look at the denominators we have. They are 2 to the power of 27, 2 to the power of 25, and 2 to the power of 24. 27 is greater than 25, which is greater than 24. That means 2 to the power of 27 is the largest denominator. 2 to the power of 25 is the middle. And 2 to the power of 24 is the smallest denominator. Therefore, 1 over 2 to the power of 27 is the smallest. 1 over 2 to the power of 25 is the middle. And 1 over 2 to the power of 24 is the largest. So in ascending order, which means smallest to largest, we have 1 over 2 to the power of 27, then 1 over 2 to the power of 25, then 1 over 2 to the power of 24. Going back to our original expressions, this means 8 to the power of minus 9 is less than 32 to the power of minus 5, which is less than 4 to the power of minus 12. And there you have it. The key was to rewrite everything with the same base and then compare the exponents by converting them into fractions. Remember, with positive bases greater than 1, the larger the exponent, the larger the number. Even with negative exponents, the ordering logic still holds, and thinking of them as 1 over a number makes it even clearer. If you found this helpful, please give it a like, share it with your friends, and do not forget to subscribe for more interesting math puzzles. Thanks for watching, and I will see you in the next video.